Hello and welcome to This Week in India Science. I am Subhra Priyadarshini. Four big stories this episode: why rising paper retractions are forcing national reform, a potential region-specific solution for snakebite treatment, India's sprint into biofoundries, and why a strange sequence of solar eruptions lit up Ladakh in red auroras last year. First up, a large analysis of retractions over 40 years places India third globally for life science paper retractions. The menace is rising. Part of the reason that the National Institutional Ranking Framework, NIRF, will now count retractions in its university rankings and penalize institutions with persistently high numbers. Co-author of the Life Sciences Retraction Study, Subhra Bhattacharya, a Research Integrity Officer at INSTEM in Bengaluru, offers a crucial corrective.
Retractions are not just a red flag for misconduct, they are mirror to our broken systems of oversight, training, ethical review. Without structural reform, we will keep mistaking the symptoms for the disease.
Now, that complexity is important. The team found nearly a quarter of India linked retractions stemmed from ethical or regulatory non compliance, not always deliberate fabrication. The concern among experts is that blunt penalties could discourage honest corrections or lead universities to bury problems rather than fix them. A single retraction for honest error, for instance, should not carry the same weight as a pattern of misconduct.
I think any sanction or metric can lead to unintended consequences. It's certainly not a bad idea to, shine the spotlight on problematic behavior that's leading to retractions. And in the short term, if that means counting retractions, that's reasonable.
Now that's Ivan Oransky, co-founder of Retraction Watch.
On the other hand, retractions don't happen automatically. So universities can block retractions or at least delay retractions. Universities could threaten to sue publishers if they retract papers from their faculty. Unfortunately, a lot of publishers react badly to risk like that. And so they might delay or even avoid retracting. So I think that's a real risk. A better solution would be to stop focusing so much on publications and citations and go way upstream, because that's why this happens. This decision, it reflects awareness, which is a positive. What it doesn't do is attack the problem at its source. Publisher perish is real all over the world, including here in the US, but it is particularly pernicious in countries that are trying to accelerate their growth and their rankings.
So what's the path forward? Bhattacharya and others argue for multi-level reform, robust research integrity officers at national and institutional levels, structured training starting in undergraduate programs, and machine-readable registries so that retracted work is visible and downstream citations can be traced.
We need to move beyond punishment and build a true integrity infrastructure, which basically means having trained research integrity officers, functioning ethics committees, and real consequences for the institutions that look the other way.
If India wants a global research footprint it can be proud of, infrastructure and incentives need to match that ambition, from ethical review to training and from transparent databases to protection for whistleblowers. Read a news explainer I put together for Nature India this week. Now, here's a story that could change thousands of lives. India has relied on horse-derived antivenoms for more than a century. That's life-saving, yes, but slow, bulky, and often mismatched to regionally varying venoms. Now, researchers in India and the UK have shown that small molecule drugs, which are basically repurposed enzyme inhibitors, can fully protect mice from Russell's viper venom. This study tested three drugs: Veresplidib, which blocks phospholipase A2, a venom enzyme that rips apart cell membranes; myrimastat, a metalloprotease inhibitor originally developed for cancer; and nafamostat, which blocks serine proteases. The punchline here is Veresplidib and myrimastat together neutralized venom across diverse populations. And in many cases, one drug alone was enough. The team even delayed giving the drugs by 30 minutes after the bite and still saved every animal. Karthik Sunakar of Indian Institute of Science, Bengaluru, the paper's corresponding author, put it plainly.
An effective solution against Russell's viper bites would essentially solve India's snakebite problem.
Russell's viper is implicated in more than half of the country's estimated 58,000 snakebite deaths each year. What makes this work especially important is the geographic mapping. Venom composition varies from West Bengal to Rajasthan. West Bengal venoms needed both these drugs. Rajasthan's could be neutralized by Veresplidib alone. Venom biologist Sunandan Das told us what this shows is that enzyme interactions in the venom can be surprisingly interdependent. In some cases, blocking one enzyme renders the other ineffective. Why does all this matter? Antivenoms require cold storage, hospital infrastructure, and are made by immunizing horses with a small set of venoms, which means that they don't always match local snake populations. Small molecule inhibitors are stable, portable, and crucially modular. The researchers say this approach lets you add or remove inhibitors depending on snake species and region, something conventional antivenoms can't do. The next step, of course, is human trials. The team is in talks with the Indian Council of Medical Research. Challenges remain: dose selection, safety in humans, delivery routes. But this could become a field deployable stopgap that buys victims hours, even days, until they get to a clinic. We go from life-saving drugs to high-speed labs now. India is building a network of biofoundries. These are highly automated facilities that program microbes to make fuels, cosmetics, and specialty chemicals. The new public biofoundry at the International Center for Genetic Engineering and Biotechnology, ICGEB, in Delhi, uses automation and AI to run the classic DBTL loop. That's design, build, test, learn at scale. Syed Shams Yazdani, head of the synthetic biology group at ICGEB, summed it up with a line that's already getting quoted.
It's like designing your dream car, only here the chassis are microbes.
Robots assemble genetic circuits, test dozens of microbial strains in parallel, and feed results into machine learning models that refine the next design. What used to take months now takes just weeks. Taslim Arif Syed from CCAM highlights why biofoundries do matter.
Biofoundries help avoid product stagnation and attract investment in new bio-based technologies.
The Chennai Biofoundry at IIT Madras, for instance, is already working on animal-free production of ingredients like hyaluronic acid and building strains that can valorize agricultural waste, such as lignin. But of course, speed raises questions. India lacks enough trained strain engineers, process biologists, and biofoundry operators, and regulation needs to catch up. New capabilities mean new biosafety and biosecurity considerations. The labs promise huge industrial opportunity, but to realize it, India needs practical training programs and rules that protect people and the environment without stifling innovation. On 10 May 2024, skies over Ladakh burst into color. Auroras far south of their usual range. Researchers at the Indian Institute of Astrophysics have now traced the cause. Not just a single solar blast, but a series of 6 coronal mass ejections that collided, merged, and formed a complex magnetic structure on their way to Earth. Using data from NASA and ESA spacecraft, the team found that these coronal mass ejections interacted between 54 and 144 solar radii from the Sun. The structures at times resembled two twisted magnetic braids wrapped together. When they arrived on Earth, they carried shock and heat signatures that made this storm the most intense in 2 decades. Now, why does this matter? These merged eruptions are harder to forecast than isolated events. They can amplify geomagnetic effects, disrupt power grids, scramble satellites, and, as we saw, paint skies over the Himalaya. The researchers say continuous monitoring and improved heliospheric models are essential if we want better space weather warnings. That's our roundup. This week in India Science, we heard about enzyme-blocking drugs that could change how snake bites are treated, hyper-efficient biofoundries, reprogramming microbes, a rare solar storm that lit Ladakh skies, and hard questions about research integrity that India's universities must answer. You will find links and full citations in the episode notes at www.nature.com/natindia/podcasts. If you liked this episode, please subscribe, share, and tell us what you'd like to hear about next. I'm Subhra Priyadarshini. Thanks for listening. I'll be back with more next week.